In this video, we're going to go over absolute value equations. So as a reminder, absolute value is the distance from zero. And whenever we are measuring distance, distance is always positive. Okay, so if you're in a car and you go 2 miles forward and then you back up for a mile on your speedometer, it's going to say that that car has traveled 3 miles. Because it doesn't matter if it's going forwards or backwards. Distance is distance. Okay. So let me get a scratch piece of paper out real quick. Okay, so when you have absolute value, if you have absolute value of -7, the absolute value of that is 7. The absolute value of +7 is still 7. We're not changing the sign. Whatever is in these bars for absolute value comes out positive, whether it started negative or positive. So when I want to solve this equation, we have the absolute value of x is 8. Okay, this is kind of as simple as this can get. What number can I plug in here for x to make this equal 8? Well, first we could have that x equaled 8. Because the absolute value of 8 is 8. Or, hopefully you are thinking that x could also equal -8. Because the absolute value of -8 is still a +8. So the absolute value of x equals 8 means x could equal 2 numbers. It could equal 8 or -8. You got 2 answers. So on B, we're going to use the same principle as we do here to solve these. Once I have this absolute value by itself, and what I mean by that is this one's not by itself because we have the absolute value +3 over here on this side of the equation. Once we get this by itself, I know that I could have either a 5 or a -5 in here to get this answer to equal 5. So my two equations are 2x + 3 equals 5, or 2x + 3 could equal -5, just like we did here. I said what's inside that absolute value, which happened to both be x, could equal the positive or the negative. I'm saying whatever is inside these brackets, 2x + 3 can equal 5 or -5. So now solve these. So on this first one here, really on both of them, we're going to do the exact same thing, but I'm going to subtract 3 to get 2x equals 2, divide by 2, and x is 1. Over here, do the same 2 steps. We're going to subtract 3. You get -8, divide by 2, and x equals -4. So plug these in and check them. If I plug in 1, we'll have 2 times 1 is 2, plus 3 is 5. The absolute value of 5 is 5. If I plug in -4, we get 2 times -4 is -8. -8 plus 3 is -5, and the absolute value of -5 is 5. So these both work. Okay. Let's do the same thing on C, but as I said, this has to be isolated first. So before I can break this apart and do two separate equations, I've got to isolate this by subtracting 3 over. So I have the absolute value of 1 minus 3x equals 10. Now that I have this absolute value isolated, now I can break it up into my 2, but do not break it up into your 2 equations before you get this by itself. So from here, we will have 1 minus 3 equals the positive 10, or 1 minus 3 equals the negative. We'll do the same thing to both, but if I just solve this first one first, I'm going to subtract 1. And I get negative 3x equals 9. I will divide by negative 3. And I get x equals negative 3. Okay, or do the same 2 steps over here. We're going to subtract our 1, which cancel. I've got negative 3x equals negative 11. Divide by negative 3. And I get x equals, I can't reduce 11 over 3, but negative over negative is positive. And so these are my 2 solution sets. Okay. Make sure though, you isolate this first. So here on D, you've got to do the same thing. This absolute value is not by itself because I have a plus 3 on this side of the equation. So let's subtract this over first. So we have the absolute value of t minus 4 equals negative 3. What is different about this one than the first 3 that we did? Hopefully you said that it equals a negative number. And what did we say about absolute value? That absolute value is always positive. There is no possible way to have anything in this absolute value and come out to a negative number. It's always going to be positive. So when this happens, we are going to have no real solutions because absolute values are never negative. So therefore, we have no real solutions. So once you isolate that absolute value that equals a negative number, you've got no solutions or no real solutions.